Hello everybody, welcome to the third episode of Inequality. Today we look at a film, the Bernoulli Inequality. So the Bernoulli Inequality are the following. If x squared equal to minus 1 and alpha is between 1 and 0, then we have 1 plus x power of alpha is less or equal than 1 plus alpha x. If alpha is less than 0, or alpha is greater than 1, then the inequality is reversed. We got 1 plus x power of alpha greater or equal than 1 plus alpha x. Before we go into prove that, so the idea of proving that, I call it the sketch of proof, are the following. First, in the first case, alpha between 1 and 0, we first assume that alpha is rational, that is, we can write that alpha as m over n for some m and m as integers, and m is less than m, greater than 0. And the second, we assume alpha is between 1 and 0, and alpha is irrational. Now the third one, we look at 1 plus alpha x is less than 0. The fourth one, we look at if 1 plus alpha x is greater than or equal than 0 and alpha is greater than 1. The fifth one, if alpha is less than 0 and 1 plus alpha x greater or equal than 0. So let's get started. Proof. So the first one, keep that in mind. First one is we assume that alpha is between 0 and 1 and alpha is rational. Okay, then 1 plus x power of alpha is equal to 1 plus x power of m over n, and that we can return as 1 plus x power of m square root of m, and that is equal to 1 times m minus n times 1 plus x power of m and square root of n. And notice that this is the geometric mean. Like what we're showing previously, we know that geometric mean is always less than arithmetical mean, so we got 1 plus 1, that is m minus m many copies, less than 1 plus x 1 plus x, and there m copies over m, so that is equal to m minus m plus m times 1 plus x over m, and that gives us m plus mx over m, and that's exactly 1 plus m over mx. Remember that we let alpha equal to m over n, so it's equal to 1 plus alpha x. That is what we want in the rational case. Now the next case, we assume alpha is irrational, and alpha also between 0 and 1, so we let R1 Rn be the sequence of rational numbers such that Rm goes to alpha as n goes to infinity, and Rm between 0 and 1 for all n. Therefore, since we know that 1 plus x power of Rm is less than or equal than 1 plus Rn x. Since Rm is rational, so we're just proving that bit above. So since Rm rational, so we can use the result we have proven it above. Therefore, we're taking limit to the both sides. N goes to infinity of 1 plus x of Rn less than equal to. And that is true for all m as well, or m. So by real analysis, we know that we can just take limit to both sides. We got 1 over x power of alpha less than equal to 1 plus alpha x. So we got the first case is proven, so let's highlight that. And also for the equality, only choose when x is equal to 0. So x is equal to 0, we got the inequality holds. The equality holds. So let's highlight that. When x is non-zero, we got 1 plus x power of alpha less than 1 plus alpha x. For alpha between 0 and 1, x greater than equal to minus 1. So that's the first part of Bernoulli's inequality. So now let's look at the second bit. The third one, we assume that if 1 plus alpha x is less than 0, and since x is greater than or equal than minus 1, therefore 1 plus x is greater or equal than 0, therefore 1 plus x power of alpha is greater than or equal than 0, which is greater than 1 plus alpha x. So the third case actually is the obvious case. So the third one, now we assume that 1 plus alpha x is greater than or equal than 0, and alpha is less than 0. Therefore, we got that minus alpha is greater than 0. Next, we select a large positive integer m such that minus alpha is less than m. Therefore, we got that minus alpha over m is between 1 and 0. And that is taking back us into the first case where alpha is between 0 and 1. So we got is, by using the result we just proven, we got 1 plus x power of minus alpha over m is less than 1 plus minus alpha over m times x. That is equal to 1 minus alpha over m x. And notice that and then we're taking the reciprocal of both sides, since that is greater than 0, so we can divide that 1 plus x power of alpha over n is greater than or equal than 1 over 1 minus alpha n over x. And since this is the geometric series, if we notice that, so okay, since this is geometric series, then we can divide that as 1 plus alpha n x plus alpha n x squared plus all the way, which is greater than 1 plus alpha n over x, so that is greater than or equal to 1 plus alpha n over x. Then next we taking the nth power to both sides. Then we get 1 plus x power of alpha is greater than or equal than 1 plus alpha over n x power of n, and that is greater than 1 plus m dot m alpha x, and that is 1 plus alpha x. This is true because since m is greater than 1. Okay. Okay, the fifth one is if 1 plus alpha x greater than or equal than 0 and alpha hang on. And alpha greater than 1. Therefore, we got 1 over alpha is between 1 and 0. Therefore, 1 plus alpha x power of 1 over alpha is less than or equal to 1 plus 1 over alpha times alpha x. That is happening in the first case. That is equal to 1 plus x. And taking power of alpha to both sides, we got 1 plus alpha x is less equal than 1 plus x power of alpha. And also, notice that the equality only holds when x equal to 0. So we summary up this is when x is non-zero, alpha is greater than 1 or alpha is less than 0, should be also x equal to minus 1. We have that 1 plus alpha x, 1 plus x power of alpha is greater than 1 plus alpha x. And that's all I got for today's. And see you guys in the next episode.